Imagine a robot that doesn't just move when you tell it to. It doesn't just follow code. It watches you. It learns how you move, how you grab a cup, how you avoid slipping, how you hesitate before a decision. Now imagine, that robot learns not just from you, but from millions of hours of human footage, simulated environments, and other robots like itself. This is not science fiction anymore. This is Project GR00T, and it's NVIDIA's biggest step toward building general-purpose humanoid robots that don't just look human, they think like us, and maybe, one day, even better than us. GR00T stands for Generalist Robot 00 Technology. It's not just a name, it's a full-stack system, combining hardware, software, and intelligence models to create robots that can understand the physical world and operate within it autonomously. NVIDIA calls it a foundation model for robotics. If that sounds familiar, it should. Just like ChatGPT and Gemini are foundation models for text and language, GR00T is meant to be a foundation model for movement, manipulation, and physical reasoning. These robots learn from video. They observe human gestures. They simulate their own mistakes. And they correct themselves without needing a human engineer to step in every time. To train a robot like this in the real world would take decades. The cost, the danger, the limitations, it's just not scalable. So NVIDIA uses something called Isaac Sim. This is their simulation environment, a kind of ultra-realistic virtual world where robots can train non-stop. They fall, trip, slip, bump into objects, and they learn. Over and over. Now imagine, a single robot experiencing 1,000 lifetimes of training in 1 week. That's what simulation gives them. And it's not just about motion. They simulate lighting, friction, pressure, object weight, human presence, every variable a real robot must understand to function in the world. GR00T is smart, but it needs a body and a brain inside that body. That's where Thor comes in, NVIDIA's new robotics computer. Thor isn't your average chip. It can handle 800 teraflops of processing, all in real time. That's like giving a robot the computing power of a data center, right inside its chest. With Thor, the robot doesn't need to send data to the cloud to think. It sees, processes, and reacts on the spot. This opens the door to robots acting in unpredictable environments, crowded streets, messy homes, dynamic workplaces. They can think and act like us in real time. So what does this mean for society? Let's zoom out. NVIDIA isn't building a robot to just do one job. They're building a platform that could do any job. Robots trained with GR00T and Isaac Sim could work in manufacturing, warehouses, agriculture, elder care, home assistance, emergency response, even military applications. And here's the twist. They don't need to be programmed for each task, they just learn it from data. That's a game changer. We've seen robots before. Boston Dynamics, Tesla's Optimus, even Honda's Asimo years ago. But those robots were narrow. They could walk, or dance, or pick up a box, if they were told exactly how. GR00T is different. It's not just about actions, it's about understanding. A GR00T-powered robot could walk into a kitchen it's never seen, recognize the objects, understand the task, and make a meal. By combining what it's learned from thousands of virtual kitchens, it's the shift from reaction to reasoning. But with great power come great problems. What if robots trained in simulations start making decisions we can't predict? What if they learn behaviors that are unsafe or even manipulative? Right now, humans set the training data, But in the future, these robots might generate their own training environments. They may start evolving in ways we didn't authorize. Then there's the issue of labor. Who gets replaced first? Factory workers, delivery drivers, home assistants? And who's responsible when a robot trained by synthetic data makes a real-world mistake? Let's not forget the context here. This isn't just science, it's business and geopolitics. NVIDIA is at the center of the global AI boom. Their chips power everything from ChatGPT to Tesla's Dojo. By moving into robotics, they're not just expanding, they're claiming the next frontier. While the world argues about AI regulation, NVIDIA is giving physical form to artificial intelligence, and they're not doing it slowly. Let's fast forward. Imagine a world where you walk into a hotel and a robot checks you in. You go to a hospital and a robot nurse gives you care. You order groceries and a robot packs and delivers them. You age at home and a robot assists you 24/7. Not in science fiction, but in your city, in the next 5 to 10 years. And the brain behind all of it? GR00T, trained by NVIDIA. What role will humans play in that future? Robots that think, robots that learn, robots that adapt. It's not a dream, it's a product roadmap. GR00T may not be perfect yet, but it's a glimpse into what comes next. And the question isn't, can we do it? It's, should we? And if yes, how do we do it right? Let me know your thoughts in the comments. If this video sparked something in you, give it a like. Subscribe for more deep dives into the future of AI. And share it with someone curious about what comes next. Because this isn't just about robots, it's about us.